which is basic trigonometric equations. Basic in a good way. And by the end today, you're going to be able to solve equations. So let's talk about how the equations are different than the identities we've been doing. So identities are going to be true for every value of theta. Right? It's going to work no matter what theta is. But equations are only true for certain values of theta, not all of them. So what we're going to be doing is solving to find what values of theta would make it true. So I gave you a unit circle, so you could just reference that. But you won't have a unit circle on your test, so I'm going to go over strategies with you to help you remember where certain points are on the unit circle. And speaking of your test, your Chapter 7 test is next Wednesday. We only have 2 more sections, 7.4 and 7.5, which we will do today and tomorrow. For example 1, we are going to solve the following equation. We have the cosine of theta, which equals negative root 2 over 2. So the first thing we want to identify is what is 1 period for cosine. So when we think back to Chapter 5 and our graphs, remember that cosine has a period of 2 pi. What does sine have a period of? 2 pi. What about tangent? Pi, okay? So what we're going to do is find the solution in 1 period. Well, 2 pi also happens to be the distance of 1 time around the unit circle. So what we're going to do is find where on the unit circle is the cosine negative root 2 over 2, or where on the unit circle is the x value negative root 2 over 2. So I know that cosine is positive root 2 over 2 at pi over 4. Because I'm looking for the negative values, what I would do is I would say, oh, well, I know cosine is negative in quadrant 2 and in quadrant 3, so I would find those values. Keep in mind this is pi, so if I go a quarter backwards, I would be at 3/4 pi, and if I go a quarter forwards, I would be at 5 pi over 4, or 5/4 pi. Right? So if I'm finding the solution just in 1 period, then the solution would be 3 pi over 4 and 5 pi over 4. Okay, so the solution in 1 period would be in the interval from 0 to 2 pi. And this is how you'll commonly see that interval displayed. So it means you start at 0, you include 0, but you don't include 2 pi. Because 0 and 2 pi are the same place, so you would just write 0. So if this is in 1 period and I want to find all of the solutions, what I can do is use a variable that represents an integer. So for all solutions, it could be at 3 pi over 4, or it could be at any rotation of 3 pi over 4. So I would just have to add 2 pi to find the other point, okay? And I could do that as many times as I wanted. So we would just write this as 3 pi over 4 plus 2 pi times k, and 5 pi over 4 plus 2 pi times k. And this is going to be where k is any integer. So it has to be an integer value. That means it's going to be a negative or a positive whole number. Okay, because you can go forwards around the unit circle, okay, which is counterclockwise, or you could also go backward, which is clockwise, and that would be a negative. Okay, so to represent all solutions for cosine, you're going to have to add 2 pi k onto your solutions. Questions for me so far? All right, let's look at the next one. Okay, so for B, we have the tangent of theta is equal to 5. Now, what are the tangent exact values on our unit circle? Root 3 over 3, 1 and root 3, and then we'd also have 0 and undefined at like your pi over 2, your 3 pi over 2. So this is not an exact place, not an exact value on your unit circle. So in order to find what theta is, we have to use the inverse function. So I'm just going to make a little note. So you are going to use the inverse function if the given value is not an exact value on the unit circle. Okay, and then whenever we do that, we're just going to round to 2 decimal places. All right, so then for the tangent, what is 1 period for the tangent? It's pi. Okay, so the first thing I'm going to do to find theta is to do the inverse of 5. Now, everything we're doing is in radians. So you do want to check your mode. Make sure that your mode is in radians. Okay, mine is. If the degree is highlighted, you'll need to highlight the radian and press enter. And then I'm going to use my inverse tangent to find out what my solution is. So your test, you are going to have a calculator portion and a no calculator portion. So if I round this to the nearest hundredth, I have 1.37. So last time we added 2 pi k, but if my period is pi, then I'm just going to add what? Pi k. All right, so then my solution is 1.37 plus pi k. Right, now if I had a reciprocal function like cotangent, it would be the same thing. Okay, so it would be plus pi k. And if I had a reciprocal of cosine or sine, secant or cosecant, it would be plus 2 pi k. All right, and then C and D say for those 2 parts, we're going to solve, which is just like what we did above, and we're also going to list 6 specific solutions. Okay, so I will help you with that part. So the first part we're going to solve like normal. So 0.28, is that an exact value on your unit circle? Nope. So then if it's not an exact value, then we're going to have to use the inverse. Okay, so your first step to find theta is to use the inverse of cosine. Okay, so when I do my cosine inverse, I get 1.29 rounded. Okay, so one of my solutions is going to be 1.29 plus what? So what's the period for cosine? Is it pi or is it 2 pi? 2 pi, okay? So one of my solutions is 1.29 plus 2 pi k. But let's think back to the last one that we did that was cosine. So if we go to the, if we look at the front, remember for cosine how we had 2 places? Okay, does that happen with all or most of the values with cosine? Yeah. See how I have 1/2, 1/2? That happens 2 places. Root 3 over 2, that happens 2 places. The only ones that don't happen 2 places are -1 and 1. Okay? Every other one has 2 places. Okay? And those are special because they're right on the axis here. So that means there are going to be 2 places where the cosine value is going to be positive 0.28. So notice that this is going to be positive. Okay, so if the cosine equals 0.28, 0.28 is a positive value. Okay, so the cosine is positive in what two quadrants? What two quadrants is the cosine positive? 1 and 4. Okay. 1.29, do we know what quadrant that's in? Okay, so do we need a reminder, or are we just being silent? So remember that half of the circle is what? Pi, right? And what is pi in terms of decimals? 3.14. So half of that would be 1.57, right? Okay, so 1.29 is in what quadrant? Okay, it's in quadrant 1, right? So now what we have to do is find the solution in quadrant 4. We do that using reference angles. Okay, so what I do is I just make an estimate of where 1.29 is. Okay, I'm going to say it's right there. What that represents is this angle. Okay, so this angle is 1.29. So I'm going to use the reference angle in quadrant 4. So in quadrant 4, okay, this would be the reflection, and this would be 1.29. Okay, those would be the same distance. What you're trying to find is the angle that starts at 0 and goes all the way to quadrant 4. All right, now if we know that what's in blue is 1.29, I'm trying to find the part that's in pink. How can I find that?
Take 3 pi over 2, then add 1.29 to that, and you have it?
You would have to, if you did the 3 pi over 2, you'd have to add this little part. Which you could find. Yeah, Liam.
It would be 6.28 minus 1.
Okay, so you can take 2 pi, right? So you can take the whole circle 2 pi and minus the 1.29, which is equivalent to the 6.28. Okay, so 2 pi minus 1.29. Anytime you're in quadrant 4, if that's what you're trying to find, you can always do the 2 pi minus the 1.29, which is going to be 4.99. So then your other solution is going to be 4.99 plus 2 pi k. Okay, so those are your two solutions. Now we're going to list the 6 specific solutions. Okay, so one specific solution is just the 1.29. What I usually do to find the other ones is you can think of it as plugging in values for k. So if I plugged in 1, right, if I would just add 2 pi. So if I did 1.29 plus 2 pi, I would get 7.57. That would be another one of my specific solutions. And then you could keep doing that. Okay? You could add 2 pi again, or you could also subtract. If you do 1.29 minus 2 pi, you could do it that way. And then you get negative 4.99. Then you do the same thing with 4.99. So if I plugged in 0 for k, I'd get 4.99. If I added 2 pi, I would get 11.27. If I took 4.99 and subtracted 2 pi, I'd get negative 1.29. Okay, and then I'm just going to write a little note for you. So to get specific solutions, add or subtract original solution. Okay, so let's see how we can do on part D. Okay, hopefully some of you were already thinking about that. So your first step is similar. So you're going to find theta by doing the inverse. Did some of you already do that? Yeah, what did you get? 0.28. Okay, so this is a special point where it happens to be the same as what you plugged in. That's fine. So then what we have to do is find where our other equation is because it's sine. Okay, so for sine and cosine, you're going to have two different places. Okay, for tangent, you're going to have one, like we had here. Okay, so if we get 0.28, we know that's in what quadrant? Quadrant 1. Now, this is positive. Okay, sine is positive in what two quadrants? 1 and 2. So we already found the solution in quadrant 1. So we have to find the one in quadrant 2. So again, we're going to use our reference angle. Okay, so what I'm going to do is the reflection in quadrant 2. So this part is 0.28. And then again, what you're trying to find is you want to start at the terminal value, which is 0. And you're trying to find this angle that I just highlighted. Okay, when you know that this is 0.28. Okay, do you guys have any ideas on how we can find that decimal? Yeah, it's going to be the pi minus. Okay, so it'll be pi minus 0.28. Because see how the green and the blue together make up half the circle, which is pi? So then you get 2.86. Okay, so then your solutions are going to be 0.28 plus 2 pi k and 2.86 plus 2 pi k. Okay, and then you're finding your specific solutions. Okay, so I'm going to start with 0.28, and then if I add 2 pi, I'm going to get 6.56. If I take 0.28 and subtract, I get negative 6.00. And then I can do the same thing with 2.86. I can add 2 pi, and then I can take 2.86 and subtract 2 pi, and that gives me my list of specific solutions. Okay, now moving down to example 2, you're finding all solutions of the given equation, and I told you here that you may have to factor. You definitely will need to factor. For ones like A, we can just go ahead and solve. So we're trying to get theta by itself. The first thing I would do is add over 1. The next thing I would do is divide by 2 so that I have the cosine squared equals 1/2. Now, because it's squared, I have to take the square root of both sides. When you take the square root, you have to remember it's going to be plus or minus. The square root of 1 is 1, so this is 1 over root 2. What am I going to do next? I can't leave it with the root 2 on the bottom, right? So rationalize, yep, multiply the top and the bottom by root 2. So the cosine of theta is plus or minus root 2 divided by 2. Okay, now this is saying that the cosine of theta equals positive root 2 over 2, and that the cosine of theta equals negative root 2 over 2. So I have to find all of those possible answers. So when I think of positive root 2 over 2, we know that positive root 2 over 2 occurs at what value? Pi over 4. Okay? The other place where positive root 2 over 2 occurs is here at 7 pi over 4. Okay? Then the negative values are going to be here, which is at 3 pi over 4. And then here. If you don't have these memorized, really all I'm doing is thinking of this in terms of you have pi here, and if you added a quarter, you get 5 pi over 4. Right? So then I have these four answers. So usually what we would do is write out all four of them and add what to it? 2 pi k. But see how these are directly across from each other? What you can do is write a simplified answer. Okay? And that's what you'll have to do, is write a simplified answer. So look at how they're straight across the circle from each other. If they're straight across the circle, what's the distance from one to the other? 180, right? Okay, so it would be pi. So what I can do for my solution is I can write this as pi over 4 plus pi times k. Is there another way that I could write that same solution? That's how you could write this one. Yep. JC?
I have a question. Why would you use only pi k instead of 2 pi k?
So because of the plus or minus, it's going to form these special relationships where they're pi k across from each other. I'm not done with my solution yet. Okay, so this is going to be the first part. You could also write this as 5 pi over 4 plus pi k, and then I'm going to have to write the other pair of solutions, which is going to be formed by these two. Okay, so the first one is representing the blue line. This one is representing the green line. And I always just choose the first two on the unit circle. But instead of 3 pi over 4 plus pi k, you could also do 7 pi over 4 plus pi k. So the reason why we do that is because if I start at 3 pi over 4, if I go halfway around the circle, where do I end up? At 7 pi over 4. Okay, so I don't want to write two equations that are plus 2 pi when I can write a simplified equation of just 3 pi over 4 plus 7 pi over 4. It doesn't matter which one of those you choose though. So same thing with this. So if you had pi over 4, if you added pi, you get to 5 pi over 4. If you added pi again, you get back here. So see how you're going to hit every point? Okay, so then that's why we're going to rewrite it in terms of pi k instead of 2 pi k. Okay, so you have to write your equations in simplest form. Okay, now for the next one, I just have the secant squared of theta minus 4 equals 0. So the secant squared would equal 4 if I added that over. And then I'm going to take the square root. So the secant of theta is going to equal plus or minus 2. So that means that my secant either equals 2 or the secant equals negative 2. So let's think of this in terms of cosine. If the secant is 2, what's the cosine going to be? 1/2, because what's the relationship between the secant and the cosine? They're reciprocal. So if this is negative 2, this will be negative 1/2. Okay, so then what we're going to do is we're going to find where is the cosine 1/2 and negative 1/2. Okay, so let's think of this in terms of my unit circle. Where is the cosine positive 1/2? Pi over 3. Okay, so it would be pi over 3 here, and then it would also be the reflection here. Okay, and if you think of this as 2 pi, right, if we go back a third, this is going to be what over 3? 5 pi over 3. Because if I added one more, I'd have 6 pi over 3. Here's my second spot here, which would be 2 pi over 3. This is 3 pi over 3, and this would be 4 pi over 3. Okay, so all 4 of these are going to be solutions. But again, can you simplify your solution? Do you have 180-degree relationships? Yes. Okay, so like I said, I usually choose the first one that occurs. So I do the pi over 3. But you could very well do the 4 pi over 3. And then this is plus pi k, because it occurs every half of a circle instead of the whole circle. And then same thing here. So I could do 2 pi over 3 plus pi k, but I could also do 5 pi over 3 plus pi k instead. Okay, so these are simplified solutions here. Okay, and you're not always going to have simplified solutions. We'll see that in part C. So in part C, see how you have a trinomial? Okay, so what we're going to do is we're going to factor this. Remember we did this on our worksheet at the beginning of chapter 7. If you have trouble factoring with the cosines, you can also think of this as 2x squared plus x minus 1 equals 0. And that might be more helpful. So it's like 2x and x, but instead of 2x and x, we have 2 cosine of theta and cosine of theta. Okay, so same thing here, right? We'd have 2x and x. What's going to multiply to negative 1 but add to 1? You'd have to have a plus 1 and a minus 1. So I'm going to have the same thing here, minus 1 and then plus 1. Okay, if it helps for you to write it out like this first and then like this, that's perfectly fine. Then we're going to use the zero product property to rewrite this. So 2 times the cosine of theta minus 1 equals 0, or the cosine of theta plus 1 equals 0. And then we're going to solve each of these for cosine. So for this one, cosine would be 1/2. For this one, cosine would be negative 1. Okay, so then you ask yourself, okay, where on the unit circle is the cosine 1/2? I'm going to finish the video, so if you can just leave as quietly as possible, and then you can watch the rest of this on your video. Okay. So cosine, the x value is 1/2 at pi over 3 and at 5 pi over 3. And then the cosine is negative 1 on your unit circle at pi. Okay, that's where you have negative 1, 0. So then your solutions, you don't have any that are 180-degree relationships. So it's going to be pi over 3 plus 2 pi k. 5 pi over 3 plus 2 pi k, and then pi plus 2 pi k. Okay, so if they don't have the 180-degree relationship, you're just going to leave the 2 pi k. And then at the bottom, I just said to write yourself any reminders. So to find specific solutions, you have to either add or subtract 2 pi. And then make sure that you leave in radians or decimals as given. And then another good one is to simplify your solutions if there is an 180-degree relationship. Okay, so that would be So you would add pi k instead of 2 pi k. All right, and then your homework is on the classroom calendar.